assessment of recruitability. So if the patient is hypoxic and I want to do recruitment, before I do recruitment, I should be certain that the patient is responsive to recruitment. That means it's not going to cause problems. Understand this, recruitment is a very dangerous proposition. You do recruitment, patient can have hypotension, patient can have bradycardia, patient can have arrest, patient can have pneumothorax. And these lungs are already very decompensated, they are stiff, they are actually small. So if you give the same tidal volume in that same small lung that we call as baby lung, there is a chance of overdistension, barotrauma, volutrauma, biotrauma, everything. So recruitment potentially is a dangerous procedure. So just like how fluids is a dangerous drug, where we give fluid only when it is responsive, like that you must also assess recruitment also, whether it is recruitable or not. So for that, what the Hamilton provides is the low flow PV loop. We've already done this in the past as to how to find the low flow PV loop. But say you don't have the low flow PV loop, how do you assess recruitability? So for that, we will do something called as the recruitment inflation ratio. What we understand is compliance is equal to tidal volume upon plateau pressure minus P. This is what we know. Now what is the tidal volume that we've attached here? For simplicity's sake, let's make it 400. Okay. Let's make it 4. This is for demonstration purposes. So 400 is the tidal volume. What is the plateau pressure we have over here? The plateau pressure, let's take it 25. Okay, the plateau pressure in this patient is 25. So 25 minus 5 of, let's take this 5 just for the sake of simplicity again. 5. Okay, 5. So you have 400 divided by 20. So the compliance that this patient has is 20 ml per centimeter of water. This is ml and this is centimeter of water.
Yeah.
Okay, centimeter of water. So the compliance of this patient is 20 ml per centimeter of water. This is the first thing. Okay, clear on this?
Yes.
Now, this means the compliance of this ARDS lung, if we call it ARDS lung, compliance of ARDS lung is 20 ml. That means compliance of the baby lung is 20 ml centimeter of water. Now, I need to figure out the compliance of the recruitable lung. Okay, recruitable lung. So what do I do here? Now I am going to find C recruit. Clear? Now first of all, I am going to take my plateau pressure, I am going to take my PEEP up to 15 and then drop it to 5. So 15 minus 5 is equal to 10. 15 minus 5 is equal to 10. Correct? Now this means if the compliance was 20, I am expecting it to be 200. Yeah, because it is after all tidal volume upon plateau pressure minus P. So I am just multiplying these two, so I get a tidal volume of 200. This is what I should get.
Yes.
Correct, this is what I should get. But what am I getting? Let us see. So we'll convert this to P of 15. I kept the P of 15 and I'm going to watch my tidal volume, expiratory tidal volume here. This is expiratory tidal volume that's coming over here. Can you see the expiratory tidal volume? Expiratory tidal volume is coming over here. Okay, I'm not here VTE. I hope there is no leak anywhere. There is no leak here. Okay. So, shows a very small leak though. Let's just check this out. Okay. Alright. Now what I'm going to do is I'm going to drop this to 5 immediately. And when I press it, it drops to 5. I have to watch this. Okay. Let's see what happens here. The breath that's coming now is 834. Okay,
Yeah.
after the drop. So now I have 8, let us take it as 800 ml for simplicity's sake. So now when I say my recruitable volume is 800 ml. Okay, so 800 minus 200, that is I'm removing this out, is equal to 600. That means I was expecting 200 but 600 came. Okay, so now 600. Now 600. I was expecting it to be 400 minus 200 is 200, but 600 has come here. Now I do compliance of the recruitable lung. Okay, that means 600 divided by plateau pressure minus P, 15 minus 5, which is 10, which makes it 60.
Yeah.
60 ml per centimeter of water. Understood this?
Yes.
Is coming properly?
Yes.
So now I want to find recruitment to inflation ratio, which basically means C recruitment,
C baby.
which is this, by C baby lung.
Yeah.
C recruit by C baby lung. Now C recruitment is how much? 60, whereas C baby lung is 20. So this makes it 3.
3.
Now 3 is more than 0.5 definitely. Anything more than 0.5 indicates that the patient is recruitable. So this is one patient, if there is hypoxia, I can recruit. You understand? Now recruitable, this is saying, let us see whether it is actually recruitable from the low flow PV loop. So we'll go to tools, you go to PV loop, you confirm this, okay.